We are cut off in our previous video, so I'll just wrap up the video real quick by talking about the voltage source converter here, its control algorithm, the filter, and the outputs. So starting with this voltage source converter, the specifications for this block are a little odd, again, because there's no specified forward voltage drop, which you would typically expect in a semiconductor device. It could be that the crafter of this schematic used the resistance, the internal resistance, to model that voltage drop, but I'm not totally certain on that. If we take this now, taking a look at the control mechanism for this inverter, or this the voltage source converter, which is the three-phase inverter. It's controlled by the combined signal of the MPPT, or the D block converter block up here, and the signal generated by this VSC control. Dive in here real quick. You can see it takes the primary side voltage and primary side current, and then you have a voltage regulator, a current regulator, which gets you your VQs and VD and VQ values, and then you get your U reference from this block here, and then you create a pulse from that U reference value, and then that pulse is sent to the inverter here to manage the switching. Now, the technique used in this control mechanism would be space vector modulation, and essentially it's a system where your 6 switches are controlled in order to convert that DC signal to an AC signal using pulse width modulation techniques. Now, the output of this signal goes through this inductor and capacitor blocks. Essentially what this does is it filters the output, and what we'll get is this big signal. But if we zoom in, we'll see that we have a fairly clean. So if we take a look here, we have a fairly clean sine wave produced by that inverter, and the filter helps remove any harmonics that would have been seen in that signal. Now, going back to our schematic, and so we had our inverter output pass through these filters and head to the transformer to be boosted to a 25 kV signal to be sent to the grid. Now, if we take a look at the outputs and the inputs, we have our measured power beginning at 92.89 and our output power at 91.29. And if we do the math there, that's roughly an efficiency of 98.27%. So it's a fairly efficient system. I mean, disregarding the fact that the forward voltage drops aren't included in the switches and the diodes. But it just goes to show how effective an MPPT controller is at, and VSC control are. Those pulse width modulation techniques are how beneficial they are to creating an efficient power conversion system. And that'll be the end of this video. Thank you all for watching, and have a great day.